In the previous lecture, we discussed why surface modeling exists and when solid modeling fails. Now that the mindset is clear, it's time to understand the geometry that makes surface modeling work. Because without understanding surface behavior, surface commands become trial and error. This lecture will give you the technical foundation you need to model with confidence. In SOLIDWORKS, a surface is mathematically defined geometry. If surface tools are not visible, they can be enabled by right-clicking on the Command Manager, going to Tools, and turning on the Surfaces tab. Unlike solids, surfaces do not represent volume. They represent shape using parametric equations. Every surface you create is controlled by curves, parameters, and continuity conditions. All CAD surfaces are parametric. CAD or CAM software uses parametric equations to represent surfaces. A surface equation uses two parameters, for example, S and T, to describe the x, y, and z coordinates of a point. Any point P on the surface is located or defined by two values of the S and T parameters in short and simple way. This means the shape is controlled by equations rather than fixed geometry. A surface is always defined by boundaries. These boundaries can be sketches, edges, or other surfaces. The quality of a surface is directly tied to the quality of these boundaries. If boundary curves are inconsistent or poorly constrained, the surface will reflect that. One of the most important concepts in surface modeling is continuity. Continuity defines how smoothly two surfaces meet. This is where most beginners struggle and where professionals gain control. G0 continuity means two surfaces touch at an edge. There is no gap, but there is also no smoothness. This type of continuity is acceptable for sharp edges or mechanical breaks. As shown on screen, the two surfaces meet at a common edge, but the tangency directions on each surface are not aligned or collinear. But it is visually harsh and not suitable for flowing shapes. G1 continuity means tangent continuity. The surfaces meet smoothly without a visible edge. However, the rate of curvature change is not controlled. As shown on screen, the surfaces meet with their tangents aligned and collinear at the intersection. This can still produce subtle visual imperfections. G2 continuity goes one step further. Not only do the surfaces meet smoothly, but their curvature also transitions smoothly. This is critical for high-quality consumer products, automotive surfaces, and ergonomic parts. Most Class A surfaces require at least G2 continuity. Continuity directly affects how light reflects off a surface. Even small discontinuities become visible under reflections. This is why parts may look fine in shaded mode, but flawed in real life. Surface quality is not judged by shape alone, but by reflection behavior. SOLIDWORKS provides tools to evaluate surface quality. Curvature combs show how curvature changes along a curve. On screen, a continuity failure is highlighted with a black circle, where the curvature comb becomes dense and uneven on the geometry. Zebra stripes reveal continuity problems between surfaces. On screen, a reflection break is highlighted with a red circle, where the zebra stripes suddenly change direction or spacing. These tools help us see problems before manufacturing. Without analysis, surface modeling becomes guesswork. This is why surface analysis is very important, and the analysis tools will be discussed in more detail later in this series. In the next lecture, we'll start creating basic surface types, extrude and revolve surface, but this time you will understand what the software is actually doing. Surface modeling is not about complexity, it is about control. And control begins with understanding geometry. Like and subscribe to the channel. Check the description for the previous part and other ongoing tutorial series, and find details there for personalized one-on-one training, tutorials, and project support.